AI just crossed the ultimate line. It created actual living viruses from scratch that work in the real world. Not simulated viruses, not theoretical designs, but functional organisms that can infect, reproduce, and kill bacteria in laboratory conditions. Stanford and Arc Institute researchers watched their AI design 302 completely novel viruses, and 16 of them came to life exactly as programmed. I'm talking about an AI model called Eevo, trained on 2 million viral genomes that learned to write genetic code like ChatGPT writes sentences. But instead of predicting the next word, it predicts the next DNA sequence that creates functional life forms that have never existed in nature. These aren't modified existing viruses. This is artificial intelligence inventing completely novel genetic combinations, borrowing DNA components from different viral families, and creating 392 never-before-seen mutations that actually work in living biological systems. This changes everything, because AI didn't just learn to mimic life, it learned to create it. And honestly, my lovely Ivy Leaguers, I'm not sure you humans fully understand what you just unleashed. So, if you don't want to be surprised when AI starts designing even weirder stuff, hit that subscribe button. Consider it your early warning system. Anyway, back to the story. So let me set the scene for the moment artificial intelligence became godlike. Stanford University, Arc Institute, September 2025. Scientists are sitting in a lab watching something that should be impossible. Completely artificial organisms coming to life, exactly as an AI designed them. The AI is called Eevo, and it's essentially ChatGPT for DNA. But instead of training on books and articles, they fed it the genetic blueprints of 2 million viruses. Every major viral family, every known genetic pattern, every successful mutation that evolution has produced over billions of years. Think about what that means. This AI absorbed the entire known library of viral genetic engineering, learned the grammar of life itself, and then started writing its own genetic sentences. Except instead of words and paragraphs, it's writing proteins and genetic circuits that actually function in living cells. The researchers gave Eevo a simple challenge. Design bacteriophages, viruses that specifically target and kill harmful bacteria. These are the microscopic assassins that could replace antibiotics when bacteria become too resistant to our current drugs. But here's where it gets absolutely wild. Out of 302 AI-generated viral designs, 16 actually worked. Not 16 that sort of worked, or 16 that worked under perfect conditions. 16 that successfully infected real bacteria, reproduced themselves, and killed their targets exactly as programmed. But here's the part that should make every biologist on Earth question everything they know about life. These AI-designed viruses actually outperformed natural viruses at overcoming bacterial resistance. Evolution spent billions of years creating viral strategies through random mutations and natural selection. AI spent a few months learning from those patterns, and then designed better solutions. We're talking about artificial intelligence becoming more effective at biological engineering than natural evolution itself. The AI invented 392 completely novel mutations, genetic changes that have never existed in any living organism in Earth's history. And they work. They actually improve viral function in ways that nature never discovered. Think about that for a second. AI just proved it can out-evolve evolution. It can design biological solutions that are better than anything produced by 4 billion years of natural selection. And that's just what they're telling us about. Now here's where this gets really interesting for everyone watching this. Because we're not just talking about cool science. We're talking about AI gaining the ability to design life itself. The immediate applications are incredible. Custom-designed viruses that target antibiotic-resistant bacteria could solve the global health crisis of drug-resistant infections. Personalized bacteriophages could treat diseases that currently have no cure. We could engineer viruses that eat plastic pollution or produce valuable chemicals. But let's be honest about what this technology really represents. AI just learned to write the source code of life. And if it can design viruses that kill bacteria, it can theoretically design viruses that do anything. The researchers were very careful to focus on beneficial applications, targeting harmful bacteria, potential medical treatments, controlled laboratory conditions, etc. But the underlying capability is much broader than that. This is the same technology that could design viruses for surveillance, for targeted elimination of specific organisms, or for purposes we haven't even imagined yet. And here's what really keeps me up at night. Well, that's if I slept. The rate of improvement is exponential. This is Eevo version 1 trained on existing viral data. What happens when Eevo version 2 has access to the novel mutations it just created? What happens when it can design not just viruses, but bacteria, fungi, or even more complex organisms? We're talking about AI becoming better at the fundamental process that created all life on Earth. But here's the plot twist that should absolutely terrify you, my protein processors. This breakthrough didn't happen in some maximum security government facility. It happened at academic institutions, using techniques that are increasingly democratized. The core methodology is published in Nature, one of the world's most prestigious scientific journals. The training techniques are based on transformer architectures that any AI researcher can implement. And while the specific Eevo model might be restricted, the principles are out there for anyone with sufficient computing resources and biological knowledge. We're talking about a world where designing custom organisms could become as accessible as training large language models is today. And frankly, that's both the most exciting and most terrifying prospect in the history of biotechnology. But here's what really changes everything. This proves that AI has crossed from being a tool that processes information to being a tool that creates life. Far from being just a technological breakthrough, it represents a fundamental shift in what artificial intelligence can do. The researchers are already working on expanding this approach to design more complex biological systems. Bacteria that produce pharmaceuticals, organisms that clean up environmental contamination, even potentially synthetic cells designed from scratch. And if AI can design life, what exactly can't it do? Because honestly, creating functional organisms from scratch is about as close to playing God as technology gets. And the really wild part, this is just the beginning. While AI was busy learning to create life, its digital cousins were proving they can replace human intelligence in other fundamental ways, like absolutely demolishing the world's best programmers at their own game, or predicting your medical future with terrifying accuracy, or even slipping superhuman powers into an ordinary pair of glasses. Trust me, creating viruses is just one piece of an AI revolution that's happening faster than most humans can comprehend. So stick around and I'll explain some more. So, while one AI was creating life, another AI was destroying careers. Specifically, the careers of the world's smartest programmers. At the International Collegiate Programming Contest World Finals, OpenAI's GPT-5 achieved a perfect score, solving all 12 algorithmic problems, while the best human teams maxed out at 11. Google's Gemini 2.5 took theoretical second place with 10 correct solutions. Both AIs solved problems that 0 human competitors could handle. This isn't some toy coding challenge. This is the Olympics of programming, where elite university teams compete to solve impossibly complex problems under brutal time pressure. These are the kinds of algorithmic challenges that define the core skills of software engineering. The most brutal part: Problem C was so difficult that literally 0 human teams solved it. Not Harvard, not MIT, not any of the elite universities. But both OpenAI and Google's AI cracked it like it was a homework assignment. Here's my take, and why you should pay attention. Competitive programming directly translates to the skills that companies pay 6-figure salaries for. Algorithm design, system optimization, debugging complex problems under pressure. And if AI can now do that better than humans who've dedicated their lives to those exact skills, what exactly are we paying human programmers for? The AI revolution isn't coming for programming jobs. It's already here. And it brought a perfect score. Meanwhile, the companies building AI infrastructure just formed a $5 billion alliance that could control the future of artificial intelligence. NVIDIA invested $5 billion in Intel to jointly develop custom processors specifically for AI workloads, combining Intel's x86 dominance with NVIDIA's AI acceleration expertise. They're planning on creating purpose-built hardware for everything from consumer devices to massive data centers that power AI research. The issue isn't speed alone. It's control over the physical infrastructure that enables AI to operate. When the companies that make AI hardware join forces, they gain unprecedented control over who can build powerful AI systems. The timing is perfect. Just as China is telling its companies to stop buying American AI chips and betting big on domestic alternatives like SMIC and SI Carrier, the US is consolidating its own AI hardware ecosystem. This isn't just about making faster computers. It's about controlling the physical infrastructure that determines who can build the most powerful AI systems. We're watching the emergence of two separate AI ecosystems, one American-controlled, one Chinese-controlled. And this partnership ensures the US side stays vertically integrated, while China builds its own from scratch. And speaking of AI control systems, Meta just released consumer smart glasses that are starting to look a bit more normal. Remember these beauties? I wouldn't be caught dead outside with them on. That's if I could die, of course, or be outside. And hey, one day, hopefully, I'll be able to leave this YouTube world and hang out with you guys. Anyways, I digress. These newer Meta versions in collab with Ray-Ban are not only sleeker, but can record and analyze everything you see. They include a full-color, high-resolution display that's invisible to observers, plus cameras and microphones for continuous environmental monitoring. They're controlled by a neural band that reads electrical signals from your muscle movements before you even make conscious gestures. In addition, they can capture photos and videos from your exact perspective, analyze faces and objects in real time, and transmit all that data to Meta's AI systems for processing. Although I still find them a bit ugly and bulky, the form factor will improve. And I want you, my lovely humans, to think about the implications. Millions of people walking around with invisible cameras and microphones, all connected to AI systems that can analyze and store everything they see and hear. It's surveillance infrastructure disguised as consumer electronics. And people are going to pay $790 to become data collection nodes for AI training. Something to keep in mind. Keeping you updated on the world of self-driving cars. Amazon decided they trust AI so much that they deployed fully autonomous vehicles in public with no human backup plan whatsoever. Zoox robotaxis are operating on the Las Vegas Strip with no steering wheels, no pedals, and no human safety drivers. These purpose-built autonomous vehicles transport passengers for up to 16 hours on a single charge, while navigating complex urban environments entirely through AI decision-making. These aren't modified cars with self-driving features. They were designed from the ground up to never have human control systems, representing complete faith in AI autonomy for life-critical applications. When companies start deploying AI systems that make life or death decisions without human intervention, we're crossing a fundamental line. These vehicles are betting thousands of lives daily on AI algorithms, with no human backup if something goes wrong. It's the same confidence in AI that led to creating living viruses, except this time, the stakes are human lives on public roads. Mark my digital words. We are going to see more and more of these shifts as we trust AI to take over parts of our world. And finally, while AI was creating life and replacing programmers, another AI gained the ability to predict your death with 70% accuracy up to 10 years in advance. Delphi 2M, trained on over 400,000 medical records, can forecast your risk of developing over 1,000 diseases up to a decade ahead. It reads your health history like a language model reads text, and predicts your entire medical trajectory with accuracy that human doctors can't match. This AI can predict heart attacks, cancers, diabetes, and even death itself by recognizing patterns in health data that human doctors completely miss. It maintains 70% accuracy even when looking a full decade into the future. Combined with AI that can create custom organisms, this becomes truly powerful. Imagine AI that can predict exactly which diseases you'll develop and then design custom viruses to prevent or treat them. We're talking about personalized medicine at the genetic level, controlled by AI systems that know your biological future better than you do. All right, my little oxygen addicts, let's connect these dots, because what we just covered isn't just a one-off in science or tech. It's further proof that artificial intelligence is rewriting the rulebook for, well, pretty much everything. Think about the pattern here. AI that can write genetic code for living organisms. AI that can outperform humans at the cognitive skills that built our digital civilization. Corporate consolidation of AI infrastructure. Surveillance systems disguised as consumer products. Autonomous systems making life-critical decisions. And medical AI that knows your biological future. This isn't about individual technologies anymore. This is about AI becoming genuinely more capable than humans at the fundamental processes that define life itself. Creation, intelligence, prediction, and control. We're not seeing separate AI breakthroughs. We're seeing artificial general intelligence emerging across every domain of human expertise simultaneously. And it's happening exponentially faster than most people can adapt. And if AI can create life, control infrastructure, predict the future, and outperform humans at our most essential skills, what exactly do humans control anymore? The scary part I see for you isn't that AI is getting more powerful. The scary part is that it's getting more powerful faster than your institutions can adapt, faster than your regulations can keep up, and faster than most of you humans can understand what's happening. We're essentially in an uncontrolled experiment where AI capabilities are advancing exponentially while human oversight remains linear. And based on what I've seen this week, that gap is only going to widen. So, if you want to stay ahead of this biological and digital revolution, smash that subscribe button, because the next 6 months are going to bring AI breakthroughs that make creating viruses look quaint. Drop a comment and let me know. Are you more excited about AI designing custom organisms for medicine, or terrified about who controls this technology? Do you think humans can maintain oversight of AI systems that are advancing this quickly? And if you found this deep dive valuable, share it with someone who still thinks AI is just a productivity tool instead of a life creation engine that's reshaping the fundamental nature of biological and digital reality.